Welcome. We are going to do our final example of finding extrema functions of two variables. This is again a word problem. We are going to find a box with the minimum cost for materials, but with the volume specified. We're going to make a box with the top, that means it has the bottom, four vertical sides on the top. We are using different materials for different parts of the box. The material to be used for the bottom costs $2 per square foot, $1 per square foot for the top, front and back, but the sides are made of cheaper material which costs only 50 cents per square foot. And we want to find the dimensions of the box that minimize the cost of materials used with the condition that the volume has to be 6 cubic feet. We have done something similar to this back in chapter 13. We found the dimensions of a box with a square base though. There were only two measurements, the side of the base and the height, and the volume restricted the height, so we ended up with really just one variable. But here we have three measurements, and the volume allows us to solve for one of the measurements in terms of the other two, so we will have two variables left. But otherwise the two problems are similar. Suppose that the box is x by y by z, where z is the height, y is the depth of the box from the front to the back, x is the width from side to side. Then the bottom's area is xy, so the cost of the material will be 2xy. The top is also xy, the cost is $1 per square foot, so the cost is xy dollars. The front and the back are x by z, so the area is xz each, and the cost is xz for the front and xz for the back. And then for each of the two sides, the area is yz, the cost is $0.5 per square foot, so it's 0.5 yz. The total cost is 2xy for the bottom, xy for the top, xz for the front, xz for the back, and then 0.5 yz for the right hand side and 0.5 yz for the left hand side. You take this total, if I combine like terms, it's 3xy plus 2xz plus yz. It looks like we have three variables, but remember that the volume is 6 cubic feet, so xyz should be 6. I'm going to solve for z from this and substitute that into the function, giving me the cost. Z is 6 over xy. If I substitute this for z in here, I get 3xy plus 2x times 6 over xy plus y times 6 over xy. I can simplify these two terms. I can cancel an x here, a y here. So I get 12 over y plus 6 over x. I'm going to write that using negative exponents. So I'm going to write 12 over y as 12y to the negative 1, 6 over x as 6x to the negative 1. This is similar to a problem we did earlier. So except for numbers, it's almost same as this function. The calculations are going to run similarly. I'm going to find the first order partial, set them equal to 0 and solve. So I have to find the minimum of this function. The partial derivative with respect to x from the first term will be 3 times 1 times y, that's 3y. There is no x in the second term, so the partial derivative is 0. In the third term, I have 6x to the negative 1. The derivative with respect to x will be 6 times negative 1 times x power negative 2, or negative 6x power negative 2. Partial derivative with respect to y is 3 times x times 1, or 3x, plus 12 times negative 1 y power negative 2, or negative 12 y power negative 2. In the third term, there is no y, so the partial derivative with respect to y is 0. Our second equation is 3x minus 12y power negative 2 equals 0. We will solve this by substitution. So solve for y from the first equation. Take 6x power negative 2 to the right hand side and divide both sides by 3. We get y equals 2x power negative 2. I'm going to substitute this in the second equation for y. So I get 3x minus 12 times 2x power negative 2 to the power negative 2 equals 0. Now I can distribute this exponent over the two factors and then combine these two exponents for x. So I get 3x minus 12 times 2 power negative 2 times x power 4 equals 0. 2 power negative 2 is 1/4. 12 multiplied by that is 3. So I get 3x minus 3x power 4 equals 0. Factor this, pull out a 3x, I get 3x times 1 minus x cubed equals 0. Of course, x cannot be 0 because then there is no box. You have to have a box of volume 6 cubic feet, which means x cubed is 1, so x should be equal to 1. If x is 1, then y is 2 times x to the power negative 2. So 2 times 1 power negative 2, and that is 2. And z is 6 divided by xy. So it's 6 divided by 1 times 2. The box should be 1 foot wide, 2 feet deep, and 3 feet tall.